In this video, I'll be explaining what hyperbolas are all about. Enjoy. Basically, in order to know what a hyperbola looks like, this is what a general shape of what a hyperbola should look like. So you have a graph and you have a hyperbola that's like this, okay? So this is one type of hyperbola. The other type will look something like this. Okay, so these are the two types. And what they look like is they normally look something like this. When you have the equation y is equal to some number, the over x. Okay, so in this case, you have y is equal to 2 over x. And to draw a hyperbola like this, what we can do is we can do a table of values. Okay, now in the beginning, this is what you'll be doing. But as you become more experienced with drawing hyperbolas, you can hopefully draw a hyperbola without using a table of values. So let's get started. So to find out what the y coordinate is, you substitute the x coordinate into the equation and you get the y value. So to get the value here, you need to do 2 divided by minus 10 and you get minus 0.2, okay? Then for the minus 4, you do 2 divided by minus 4 and you get minus 0.5 and so on. So I'm just going to write out the values, okay? This should be minus 4. Now, once you get to the value of 0, you realize something interesting has happened. It's interesting because you cannot divide by 0, right? When you try to substitute x as 0, it's not going to work. So it's undefined. And now once you start substituting these values in, you realize that the only difference between the values here and the values here is that these are positive numbers and these are negative numbers, okay? That these are positive numbers of the same numbers here. So I'm just going to put the same values here, except instead of a minus, I'm going to write a plus. So you have 4, you have 2, 0.5, and you have 0.2, right? Okay. Now, once you have the tail values, you can start graphing, okay? So I'm just going to write down the values here. So I'm going to start from here. When x is 0.5, y is equal to 4. So 1, 2, 3, 4. This is 4. 0.5 is somewhere here. When x equals 1, y is equal to 2. So when x equals to 1, y equals to 2. When x equals to 4, y is equal to 0.5. So 1, 2, 3, 4. Y is equal to 0.5. So somewhere here, right? When x equals to 10, 4, 5, 6, 7, 8, 9, 10. Y is equal to 0.2. So like somewhere here, okay? So then we just connect the dots, all right? So I'm not going to be good at this because I'm doing this online, but you get the basic idea. It will look something like this, okay? Now remember, this graph is actually approaching the y-axis and the x-axis. So make sure that this line does not touch the y-axis, okay? Because there's going to be an asymptote at the line x equals to 0 and y is equal to 0, okay? The reason these are asymptotes is because we know that x cannot be 0, right? Because you cannot divide by 0. And we also know that y cannot be 0 because 2 divided by, doesn't matter what number you divide, you will not get 0 if you have 2 divided by the any number. So because we know that y cannot be 0 and x cannot be 0, these are the equations of the asymptotes. Y is equal to 0, x is equal to 0, okay? Now we just have to do the same for the other side, okay? So I'm just going to do it slowly. So minus 10, minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is minus 10. Minus 0.2, that's somewhere here. Minus 4, minus 0.5, so minus 1, 2, 3, 4. minus 0.5 is somewhere here, minus 1, minus 2, somewhere here, minus 0.5, minus 4 is somewhere here. So as you can see, once you join these dots, you would get something that looks like this. Okay. Now this is not a very good drawing, but you get the idea. Okay. So from this graph, we know that from the first quadrant, as you still remember from trigonometry, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. In the first quadrant, the graph is approaching the x-axis, which is the horizontal line, and the y-axis, right? And in the third quadrant, the graph is also approaching the x-axis and the y-axis, okay? So that's the nature of most hyperbolas, okay? Now for the next one, okay? The next one says, complete the table values below and then sketch y equals to minus 2 over x. Now, there's two ways you can do this. So one way, which I call the slow way, is to actually find all the table values and sketch it out. The second way is to think of a transformation. So if you still remember, when you have a graph y is equal to something, and you have y is equal to minus that something, all you need to do is turn the graph upside down. So if you still remember with parabolas, when you have y is equal to x squared, right? Then the parabola will look something like this, right? But when you have the graph y is equal to minus the x squared, then the graph will look something like this, right? So basically, by putting a minus in front of a graph, you turn the graph the upside down, okay? Okay, so now I'm just going to do this the quick way without doing table values, but basically you turn this graph the upside down, okay? So it looks something like this. Now, in the exam, if they actually ask you to draw a graph like this, what I would strongly recommend is plot down 2 points, okay? So 1 point on this graph and 1 point on this graph. So I'm just going to pick 2 easy points here, okay? So I'm just going to pick when x is equal to 1. When x equals to 1, y is equal to minus 2. So you have 1, minus 2, okay? So that's the point. So that means I should actually draw my graph going past through that point, okay? Okay. And then here, when x equals to minus 1, y is equal to 2, right? So I'm going to do minus 1 and 2. So as you can see, it already goes through here, which I did by coincidence. But basically, this is what the graph should look like, okay? Now, if you want to double check if your graph looks correct, what you can do is you can use either GeoGebra or the Desmos to actually sketch out what the graphs will look like, okay? All right. Now, here I'm just going to summarize what features of hyperbolas are, okay? So when you have a feature of k over x, you need to know that there are no x-intercepts because we cannot divide by 0. Okay, so that means x cannot be 0. The graph has 2 parts in opposite quadrants with the same shape and size. Okay, so like I said, you can either have a graph that looks like this, or you can have a graph that looks like that, okay? Remember, these are 2 opposite quadrants because this is quadrant 1, quadrant 3, this is quadrant 2, and quadrant 4, right? Okay. If k is positive, the curve is in the first and the third quadrant. So in this case, k is positive. In other words, you have something that could, for example, y is equal to 2 of x. This is when k is positive, right? If k is negative, the curve is in the second and the fourth quadrant. So if k is negative, so such as when you have y equals minus 2 of x, then your graph will look something like this, okay? The curve approaches the x and y axis but will never touch them. These are called asymptotes. So as you can see in these graphs, this graph is approaching the x-axis and this part is approaching the y-axis, okay? But it will never touch them. So in the exam, make sure that these graphs, these lines do not cut the x and y axis because, like I said, there are no x and y intercepts. Alright, so now what this question is going to ask you is to sketch y is equal to 3 on x and y equals 5 on x on the same number plane. Now, this is basically trying to tell you how they're different, even though their shape would generally look quite similar. Okay, so I'm just going to do this. There's really no quick way to do it because I have to plot out all the points because I want to make sure I draw a nice looking graph. So just sub the values in. So this will give you what? Minus 3 divided by minus 4. Minus 0.75. This gives you minus 3. This will give you minus 6. This is undefined. This is, just remember the same values on this side, so 6, 3, 0.75. And this will be what? 0.3, right? Now, do the same thing over here, so you get 5 divided by minus 10, which is minus 0.2. This one is 5 divided by minus 4, which is what? Minus 1.25. Next one is 5 divided by minus 1, which you should know, minus 5. 5 divided by minus 0, which is minus 10. This is not available. As you know, you cannot divide by 0. Now these values are just going to be the same as these, but positive version. Do 1.25. And then 5 divided by 10, 0.5. Okay, so I made a mistake here, as you can see. This should not be minus 0.2, it should be minus 0.5. Okay. Now, time to plot in the points. Okay, so here we go. So minus 10, minus 0.3. So that's going to be somewhere here. This is minus 10. Minus 4, minus 0.75. Slightly lower, because this is minus 1, right? Minus 1, minus 3, so minus 1, minus 3. Minus 0.5, minus 6. One, 3. Okay, so I'm just going to draw this part of the hyperbola first. Okay, so you have a graph. Okay, looks something like this. And then you do the same for the other side. So 0.5, 6, 2, 3, 4, 5, 6. 1, 3. 4, 0.75. 10 minus 10, and so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you just join the dots and then draw something that looks like this. Okay, so this will be your y is equal to 3 on x, okay? Now we have to do the other one, okay? So we have to draw them on the same one. So minus 10 minus 0.5, so that's slightly lower. Minus 4 minus 1.25 is slightly lower as well. Minus 1 minus 5. Minus 0.5 minus 10. Okay. So this is just slightly below that graph there, okay? So I'm going to use a different color to make it more clear. And then for this part, it's going to look exactly the same, okay? So as you can see that over here, the y values are all smaller than the values here, and over here, the y values are all bigger, right? So in a way, you can say that the graph y is equal to 5 on x is inside the graph of y equals to 3 on x, okay? So I'm not going to go through the points, but it's going to look something like this, okay? So you can see the red one is y is equal to 5 on x. And the blue one, the black one, is y is equal to 3 on x, okay? Alright, so, and remember, for both of these graphs, they have the asymptotes. They have a vertical asymptote and a horizontal asymptote at the x and y axes, okay? Okay, now this is asking you to draw the same thing, except instead of a plus, it's a minus. So like I said before, when it comes to drawing these graphs, you do not have to do a table of values. What I'm going to do is just going to plot in 1 point, okay? And this will save you a lot of time in the exam. So for this graph, so I'm just going to say when x is equal to 1, okay? So y is equal to minus 4 on x, okay? So when x equals to 1, what does y equal to? Y is equal to minus 4, okay? And then we have to put in a negative value. So when x equals to minus 1, y is equal to 4, right? So we know that this graph will go through these 2 points. So I'm just going to plot them in. So there's 1 and there's minus 4. And here, there's minus 1 and 4. Okay. So these are 2 points that it goes through. And because we know that this is a negative hyperbola, so it's going to be in the second and the fourth quadrant. So I'm just going to draw something that looks like this. Okay, this is not very good. But okay. Now for this, the other hyperbola, we know that based on the example, we know that the graph of y equals 5 on x is inside the graph of y equals 3 on x, right? So we know that the graph of y equals minus 7 on x is going to be inside the graph of y equals minus 4 on x. But we're just going to put in 2 points anyway, okay? So I'm just going to say in y is equal to minus 7 on x. find 2 points. So when x equals to 1, what does y equal to? Y equals to minus 7, right? Hopefully you know that. When x equals to minus 1, y is equal to minus 7 over minus 1 is 7. So these are the 2 points that we can put on the graph, okay? So we have 1 and minus 7. 6 minus 7, so here. That's the one of the points. And then we have minus 1 and a 7. That's the other point, right? So like I said, you can use your knowledge of hyperbolas. We know that this one is going to be inside this one, so I'm just going to draw it. Like I said, these 2 parabolas should never touch, okay? They're untouchable. And this one should look like this. Oh. Alright, when you're doing it on paper, it's much easier to draw a good looking one. So I'm doing this on the board, so it's pretty tough here. Alright, so there you have it. 2 negative looking hyperbolas, where one of them, the red one, is inside the black one. Alright, so that's all for today.